Hello everyone, and welcome again to this class, and we'll continue from there that we were doing the example of the double pendulum, and we have calculated the equation of motion for theta 1, and now I have already written the Lagrangian because I don't want to waste time into calculating an Lagrangian. So from here itself I can go for the equation of motion for this angle for the second generalized coordinate, which is theta 2. So let us move for the Lagrange equation. Uh, so Lagrange equation for generalized coordinate that is theta 2 in our case. Now this is going to be d dt of delta L by delta theta 2 dot and minus delta L by delta theta 2. So this is going to be 0. So now I have to calculate this delta L by delta theta 2. So you see where I have theta 2 dot. So I have theta 2 dot here itself, theta 2 dot here itself. So I'm going to get this two terms. So this is going to be m2 L2 square theta 2 dot and then plus m2 from here m2 L1 L2 theta 1 dot, and I have cos theta 1 minus theta 2. Okay, this is my delta L with respect to the theta 2 dot, theta 2 angle. Now I have to calculate this d dt of this thing. So d dt of this delta L by delta theta 2 dot is I can differentiate with respect to time it, that is going to be first m2 L2 square and theta 2 double dot. So you can see here theta 2 double dot is there, and then from here itself you have to remember that when we calculated, I have told you that you have to be careful about doing this theta 1 minus theta 2. So this is going to be L2 L1 L2. First I'm going to have this for this theta 1 part, and then cos theta 1 minus theta 2 is there itself. Now I have to look for this cos theta 1 minus cos theta 2, that is going to be plus, or first if I do with respect to theta 1, so this is going to be negative minus m2 L1 L2 theta 1 dot, not double dot because we are concentrating here, this is going to be sine theta 1 minus theta 2 and then theta 1 dot, because now I'm differentiating over theta 1. And then when you do with the theta 2, because already negative will come from here, so this negative will become positive. So you have m2 L1 L2 theta 2 dot. Okay, so theta 1 dot is here, theta 1 dot is here, and I have sine theta 1 minus theta 2, and this is going to be theta 2 dot. So this is my d dt of with respect to theta dot. Now I had to calculate this with respect to theta 2. So let us calculate with respect to this delta L by delta theta 2, and theta 2 I have here and here. So I'm going to have two terms. So first one with theta 2 is going to be cos becomes, this is the negative of this, so this is cos will become sine, with negative again will be positive. This is going to be L1 L2 theta 1 dot theta 2 dot, this is going to be sine theta 1 minus theta 2, and cos going to sign with the negative sign, and then will be theta 2, so this negative will be positive, so this is going to be theta 2 positive. Okay, and the second thing what I'm going to get is from here is minus m2g L2, because this cos will become, this is sine theta 2. Okay, I don't think anywhere else I have theta 2 is left. Now that's fine. So let me try to find out this equation of motion. This is, if I put it into here, so I'm going to have all these minus of this thing, okay, all these minus of this thing. So let me see whether everything is correct or not. M2 L1, and I'm going to be cancel with the theta 1 theta 2 dot. Okay, so I think would I have written this correctly or not? I don't know. Let me clarify the Lagrangian first again. So I have M1 M2 L1 square theta 1 dot L1 L1 square theta 1 dot square, and then I have this L2 square theta 2 square. So L2 square theta, then we have this term M2 L1 L2 theta 1 dot theta 2 dot M2 L1 L2 theta cos theta 1 minus theta 2, and then I have mg L1 cos theta 1 M2 Lg. So this is, I think this is fine. Okay, so it's going to be sine, okay, fine. So what I'm going to do is okay, I did one mistake here, that this is not going to be theta 2 dot, because this is not with respect to time. So that was my confusion, that this, for this term, this is simply going to be sine theta 1 minus sine theta 2, and with the negative sign. Okay, now everything is clear. So now I'm going to put this into here. So this is going to be, if you see that if I submit this, if I substitute this, so this term M2, this L1 L sine theta 1 minus theta 2, so this is if you concentrate here, this term sine theta 2 minus theta 2 theta 1 theta 2 with a positive sign, and this is going to be okay, with this is going to be negative, negative is going to be positive. So let us try to, whether I did that, where I'm getting the mistake. So this is m square L square theta 2 dot, and then m2 L1 L2, and this is theta 1 double dot cos theta 1 minus it is okay. So m2, and then I have to have m2 L1 L2 theta 1 dot, this is going to be sine with negative sign theta 1, so that is theta 1 dot square, that's okay. And then I have m2 L1 L2 here, and theta 1 dot is here, is fine, and cos becomes minus sine theta 1 theta 2, and then this becomes positive. Okay, now let's this must be cancelled out now, because, so let's try to do this here. So if I have m2 L2 square theta 2 double dot plus m2 L1 L2 theta 1 double dot, this is cos theta 1 minus theta 2. Let us try to write it, then we will figure out what is happening, if there is any mistake of the sign or not. M2 L1 L2 theta 1 dot, this is going to be sine theta 1 minus theta 2, and theta 1 dot is going to be theta 1 dot square, I'm writing it, and then plus this is going to be m2 L1 L2 theta 1 dot theta 2 dot, and you have sine theta 1 minus theta 2. Okay, and then I have this is minus, this is minus, minus, plus, this become plus m2 L2 sine theta 2, and this term is also is plus, that is m2 L1 L2 theta 1 dot theta 2 dot, that is going to be sine theta 1 minus theta 2. So this term must cancel out each other. So what is the problem is, there is a negative sign problem. I am not able to figure it out. Here it was so with the negative sign. So what is the problem here? Okay, so if it's not cancelling out, let it be as such. So what I'm going to have is m2 L square theta 2 double dot and m2 L1. You have to you try to figure out it yourself, because if maybe they may cancel out. But now I have is in a small angle approximation, if we'll do this, cos theta will become 1, and this is this term will be 0, because this is square of the term. So I'm going to have m2 L2 square in say, if I'm not going to, so a small, in a small angle approximation. So so for a small angle, approximation, so if you do this, this becomes m2 L2 square theta 2 double dot, and then this is going to be m2 L1 L2 theta 1 double dot, is cos theta is 1, and then this is not going to contribute because of the small theta 1 dot square. And then I have this m2 GL2 sin theta 2 plus m2 GL2 sin theta 2. And now what I'm going to have is this 2 times, this is twice m2 L1 L2 theta 1 dot theta 2 dot, I have sine theta 1 minus theta 2, or say when I'm doing into a small angle approximation, this sine theta is going to be it must cancel out. So where's the problems? So I hope this is uh, it must cancel out. Finally it must cancel out. So there is some problem with this negative and positive term, and otherwise there will be no there will be no such term which in coupling these two. So this is I think in my expression what I have is m2 L2 square theta 2 double dot m2 L1 L2 theta 1 cos theta 1, and then theta 1 square is there, and so there is no such expression is there. So this is all is what I have in my final expression. So this is to figure it out, that where I'm doing the mistake. And so maybe, like, if I say, if I calculate theta 2 dot is going to be m2, this is okay, this is m2 L2 theta 2 dot with respect to theta 2, and then this is going to be m2 L1 L2, this is going to be theta 2, this is going to be cos theta 1 minus theta 2, this is fine. And this Lagrangian I have is okay. This is theta 2 theta 1 cos theta 1 minus theta 2, this is fine. And then for no, there's no such thing. And okay, so if I do m2 L2 square theta 2 double dot, this is fine for this. Okay, and now if we concentrate on this term, this is going to m2 L1 L2 theta 1 double dot cos theta 1 minus 2, this is okay or fine. And this one term will be negative and one term will be positive. So this is I don't know why this is, this must be. So anyways, we had to look for this. So I'll discuss this in my next class, or whenever I get clarification. So maybe I'm doing a bit mistake, or maybe it is true, because I don't know. So this is, I'm doing keeping it here. So I'll try to get it rectified. Right now I'm not getting the point. So now, without wasting time, let's move to the second example, that this is the second example, which is known as the elastic pendulum. This is known as the elastic pendulum. So I'll be doing this elastic pendulum. So and what is elastic pendulum? Elastic pendulum consists of we had done two problems, that is, one is a spring problem and the second one is the simple pendulum problems. If you attach these two problems, that if my the pendulum is such that I have a spring and then I have a pendulum attached to it, bob attached to it. So it's a spring part and the pendulum part, both taken together. This is elastic pendulum. So I have my Ex in this direction and Ey in this direction. This is my reference point. This is my theta, and this is my going to be, this is, so this L is basically it's not constant. This depends upon the time. So this is going to be L naught plus some x which is changing with time. So L naught is the constant part which is without any force, real length of this, and then this xt, as x varies when it moves at x varies because of this restoring force. This is going to be this thing. So I'm going to have the two component here of the velocity. This is in r direction, this is in theta direction. So what I have here is the kinetic energy. For that I had to write this, the kinetic energy here in this case is half m. So one is this in r direction, which is vr square, and the second is in the theta direction, that is transfer direction, the velocity what it is. So in r direction, in this direction, what is going to be here, this is going to be the x dot. Okay, so this is so we are basically is going to be x dot in our case with respect to this, and then v theta is going to be L naught plus this is going to be, if you see, this is r theta dot square, so this is going to be r theta dot square. This is going to be, this is L naught plus x, and this is going to be theta dot. Okay, so this is going to be okay, theta dot, and like this. So let me write it very clearly. So L naught plus x is square will be theta dot square. This is going to be v theta is going to be, this is going to be L naught plus xt, and that is going to be theta. Okay, theta dot. So I have Vr and V theta square. So I can write this Vr as square. So this is will be half m is x dot square plus this is going to be L naught plus this x square and theta dot square. So this is what you have your kinetic energy. Okay, and then what about the potential energy? Potential energy is V is this minus mg, and this is going to be this one, so this is going to be LT. So this is LT, or you can write as minus mg L naught plus xt. Okay, so this is what my mg, because I'm going down. So now I have the kinetic energy as well as the potential energy here. So I can write the total Lagrangian as is going to be half m and x dot square plus this L naught plus x square theta dot square, and you have plus mg L naught plus x, and this is going to be cos theta. Okay, and because mgl and this L here is how much depends upon this, so this is going to be cos theta. So this is LT cos theta, this length is, so it's going to be LT, okay, or you can write it here cos theta. So I have left it. And then one more potential is there because of you have the spring is, so then you have minus kx is there. Okay, so you have minus kx is there. Okay, this is because of the spring potential. One is because of this gravitational potential energy, and then the second one is because of the restoring force, because you have v equal to half kx square and then f is equal to minus kx. So your potential here is going to be plus half kx square. Okay, so you add this is minus half kx square. So my total potential which is acting on this system is going to be first because of the gravitational potential energy, and this half kx square because of the spring which is attached to it. So this is my total Lagrangian of the system, and then I can have the equation of motion. The equation of motion as I had to find this d dt of delta L by delta theta dot, and this delta L by delta theta equal to 0. So now if I find delta L by delta theta dot, if you see from here, this is theta dot here, so I'm going to get m L square plus x square, and it's going to be theta dot, and nowhere else I have a theta dot. So now I can find delta L by delta theta, in this case this one. So I have here such delta L by delta theta is going to be from here, this is going to be minus mg L0 plus x, this is cos theta becomes sin theta. Okay, fine. So now I have d dt of delta L by delta theta dot here. So delta theta dot is here, is going to be minus delta L by delta theta, or say so equal to 0. So I'm going to put this d dt of this is going to be m L0 plus x square theta dot minus, or this minus becomes plus mg L0 plus x sin theta equal to 0. So if you integrate it, if you differentiate it with respect to time, you're going to m L0 plus x theta dot, you're going to get m L0 plus x square theta double dot, and then now you had, because x is depending upon t, so I have to integrate it, because m theta dot plus m theta dot, and then this is going to be twice L0 plus x dot. Okay, so this is what from here, and then plus mg L0 plus x plus mg L0 plus x, and this is going to be sin theta, this is going to be sin theta equal to 0, or I can write this m L0 plus x square theta 2 double dot plus twice m x dot theta dot L0 plus x plus mg L0 plus x sin theta equal to 0. So now you can see that this is my equation for theta dot, first equation with respect to theta. If you get rid of mass, so then now quickly let's try to find out what is d dt of delta x by delta x dot and minus delta L by delta x equal to 0. So if delta L by delta x dot, what I'm going to have, x dot I have here, so this is going to be mx dot, so this is going to be mx dot, nothing else, there is no x dot, and then I'll have delta L by delta x, so I'm going to have delta x by delta x from here, this is m, this is going to be m L0 plus m0 2m, this is with x, so this is going to be 2m theta dot square, this is going to be twice m theta dot square, and then because and then we have L0 plus x, and the from second L will come, x from come here, mg, and then x cos theta, so this is mg cos theta. Okay, so plus mg cos theta, and then from here you're going to have this twice cancel out, you are going to have minus kx, here to have minus kx. So this is what I have. So now I put here in this equation, so I am going to have d dt of mx dot is going to be mx double dot, and then minus twice m theta dot, you have L0 plus x plus mg cos theta, and then you have minus kx equal to 0. So from here you can have this x double dot minus twice theta dot L0 plus x plus mg cos theta minus kx equal to 0. So this is my second equation of motion. So let me clear x dot is so mg cos g, and I have this there is no g, so this is going to be g cos theta minus kx. Okay, so I think this my equation is x double dot is going to be L0 plus x is theta dot square minus g cos theta minus k by this is k by mx. Okay, so this is going to be fine. So m0 L del L by del x. So this is going to be theta dot square here, theta dot square, and I didn't have twice m. This is going to be theta dot square. Okay, theta dot square. So this is going to be theta dot square, and this twice will cancel out with this. So I don't have twice here. So I don't have twice here. Okay, so this is again second equation of motions. Now if you see that, if you here in this case, if you put theta and its theta dot is 0, then this part is not going to contribute. Theta dot, if for theta dot equal to 0, and your equations of motion is x double dot is equal to minus g cos theta minus k by mx, and this is what the simple print is, or theta if theta is 0 and theta double dot is not there. If you cancel out these two things, so then you have what you have, x double dot is equal to minus k by mx, that is your spring motion. And in this equation, if you put all x and x dot component is 0, so this is not 0, this is going to be 0, and this component is going to be 0, and this component is going to be 0. So what you have is ml0. So what you're going to have is ml0 theta double dot, and then plus from here itself this is plus mg sine theta equal to 0. So this is going to be theta double dot plus g by l sine theta equal to 0. So anyway, so if you get rid of your x dot, if you get rid of theta dot, you can get the motion of a simple pendulum as well as the spring motion. So this is what it is known as the elastic pendulum, and this is very good example to see that each motion is attached to one, and then you put a certain variable to be constant, then you get the equation what you need, whether it is a simple pendulum or the spring motion. So I think this is I'll end this at this position at this time, and from the next class maybe I'll do one more problem, and then I'll switch to the variational principle calculations, because I think I have done enough for this Lagrangian equations motion. And if I get time in the last of the course, then we'll do some more problem based on the Lagrangian dynamics. Thank you very much.